those? Alright, the first one, they gave you the diagram. So in that diagram, they gave you the coordinate of m, which is the x and the y value. That's x, that's y. Then you put those values in on your diagram. Now you have the radius unknown. So you use Pythagoras and then you find the answer to be plus and minus the square root of 5. Because it's a radius, I told you guys that the radius is always positive. I choose the positive one. Now they can ask us anything. The first one is the cos of theta, which is 2 over the square root of 5, because it's adjacent over hypotenuse. I gave it as a rationalized denominator as well. We spoke about that. If you don't really have to go and like multiply with the square root of 5 top and bottom, you just use your calculator. If you put 2 over root 5 in your calculator, it will give you the rationalized answer. Okay. I just want to say again, you guys remember that when they refer to theta here, they are actually talking about this big angle here, right? But we use its reference angle, an acute angle, because then we can get it into a triangle. But you know it's the same thing there. Then they ask for 1 minus sin squared theta. It's 1 minus negative 1 over the square root of 5 squared. Then it's 1 minus a fifth, and that gives me 4 over 5. Now there's something I want you to take a look at here. It's work that we did in grade 8 as well. And it's important for the work that we're going to do today. When you have 1 plus 5 square root, it's going to be 1 plus 25. If you have 1 plus bracket negative 5 square root, it's going to be 1 plus 25. The square root made that negative positive. If it's 1 minus 5 squared, it's going to be 1 minus 25. This is where it's important to know the difference between a negative and a subtract, a minus. So this answer won't be negative, it's still a positive answer, but you are saying 1 minus 5's square. So that square can't make a minus a plus, but it will always make a negative a positive. Remember that. It's coming now. Right, next one, 13 cos theta equal to 12. You get the function alone. It's positive, so it's going to be in the first or the fourth quadrant. But then they tell you theta is from 180 to 360. So it's here and here. That's how I know it's in the fourth quadrant. Theta is that big angle, but I use the reference angle that will fit into the triangle. Cos is adjacent over hypotenuse. That's how I know it's this side that will be 12 and this one that will be 13. Then I use Pythagoras to calculate the last side. You get plus or minus 5. You have to go and look, is this going to be plus 5 or is it going to be minus 5? And it's going to be minus 5. Now you just substitute the tan of theta is opposite over adjacent, negative 5 over 12. Sin theta plus cos theta squared. Sin is opposite over hypotenuse. Cos is adjacent over hypotenuse. You do the addition sum, gives you 7 over 13, and then you square it, 49 over 169. Are you all fine? When you can.
When you can.
Yeah, like if it was square root 16, then you would say it's 4.
So you mustn't always put it, only when it's active when you must put it.
Yeah. Can I repeat your question to everyone? Tonya is asking about leaving it in square root form and when not. So this value of the hypotenuse is 13. Okay. Here we left it as a square root because it's an irrational number. The square root of 5. It cannot be calculated. That's why we leave it square root 5, because you remember the instruction with these was without the use of a calculator. That's why you cannot calculate the square root of 5. But here, this side is 13. Even if they gave you the y value and you used Pythagoras, you would get to the square root of 169. That's one that you can calculate and you must calculate. Then you get plus or minus 13. And then you decide about positive or negative. So it stays in the root if it's an irrational number that you cannot square root. But if you can square root it without the use of a calculator, then you give the answer. Right, the next one was 3 tan theta minus 4 equal to 0. You get the function alone. I see that it's positive, so it's quadrant 1 or quadrant 3. But then they tell you cos theta smaller than 0. Do you remember what that means in English? Negative. Okay, so cos is negative. Where is cos negative? Second and third. That's how I know I'm going to draw in the third quadrant. Now, don't look now. I wrote too hard. Okay, any case, if you put in the 3 and the 4 there, because tan is opposite over adjacent, it's 4 over 3. What is wrong with that thing right there? Make a note for yourself here and learn it for the exams. When tan is positive in the third quadrant, it's positive because both of them were negative. It's negative 3 and negative 4. And if you do that wrong, it's already 2 mistakes. Remember, 2 strikes you're out, ne? And we don't mark with the mistake. So this is very important. I said tan in the third quadrant is positive because the opposite and the adjacent side are both negative. Does it make sense? Just always check when you put in those values. Are you on the negative side of the x or the y? Are you on the positive side of the x and the y? With all of them, sin, cos and tan. Because when you're in the sin quadrant, in the second quadrant, remember then your x will be negative and your y will be positive. Don't put a negative at the y and the positive at the x. You have to go and check that. Right, now I use Pythagoras. You see, even though you will get the same answer, you will get it wrong if you substitute in 3 and 4. Because it's negative 3 and it's negative 4. And then you find it to be plus and minus 5. So it's a radius, it's going to be 5, always positive. Now I've got all the sides. So A asked for the sin over cos. Substitute, it's negative 4 over 5 divided by negative 3 over 5. I just wrote it with a division sign instead of a fraction over a fraction. I'm going to multiply now, but then the second one has to swap around. Multiply with the reciprocal, ne? Do you all understand? The 5's cancel out and now I get 4 over 3. Do you remember on Friday we saw something that was sin squared plus cos squared that gave us 1? And I told you guys that's an identity that we are going to learn later on. Now there are 2 identities that we learn. The first one, or actually the second one, is sin squared plus cos squared is equal to 1. The first one is happening here, but now remember you don't know this yet. And I'm just telling you this so that you get used to the idea, so when we get to identities it's not completely new. Look at what they gave you there at the top. You had tan theta equal to 4 over 5. Look at the answer that you got at A. That's the first identity. Sin over cos is tan. Sin over cos is tan. So sin squared plus cos squared is 1 and sin over cos is tan. Just always. If the angles are the same, not if it's sin theta over cos alpha, then obviously that's totally something different. But in the same triangle with the same angle, sin over cos is always tan. Okay, next one. 10 sin theta minus 25 cos squared theta. So I've got 10 times 4 over 5, negative 4 over 5 minus 25 times negative 3 over 5 squared. Here it's very easy to see that the square will not make that minus plus, because of the 25. But this is the same as that other one as well, except the coefficient was just 1. But the rules are the same. Okay, so that square will make that negative positive, but that minus remains a minus, and your answer is negative 70. Last one. I hope the 2 root 6 over 5 didn't scare you. Remember, sin, cos and tan is a ratio. It's a numerator over a denominator, and that numerator will be one side and the denominator will be the other side. So the only thing is the opposite side is 2 root 6 and the hypotenuse is 5. So if it looks ugly, don't let it bother you. So this is positive, so it's either quadrant 1 or 2, but then they say A is an element from 90 to 360, and that leaves it in the second quadrant. So this side is 2 root 6 and this side is 5. Opposite over hypotenuse. Use Pythagoras, then you get plus or minus 1. But you see this side, x, it's to the negative side, so it's negative 1. 15 tan A times cos A, you just substitute, and you can type that into your calculator as well if you want to. It's 6 root 6. Right. 30. It's just one chapter. 30. Okay. Next up, what we're going to do has to do with these angles that I've showed you all the time now. When we refer to A, that you guys know most, this is now actually a big angle, but we're using the reference angle. And when it's in the third quadrant, we know it's a reflex angle, but we're using the acute angle, and the same in the fourth quadrant. Okay, so it is very, very easy. You can copy from the board here. I'm just going to write in blue the Afrikaans. Sorry. You can write reduction formula. And then you write function values. Now today we are only going to look at the first function value, which is 180 degrees plus or minus theta and 360 degrees plus or minus theta. But there are 3 different function values. Now I want you to write down all of them as well, so that when you study at the end of the term and at the end of the year, you've got everything here. So the next one that we're going to learn about, you guys are here for 2 periods tomorrow. so we are going to do it tomorrow as well, is co-angles. Okay. And they will be 90 plus or minus theta and 270 plus or minus theta. And then the last one, number 3, is negative angles. Now negative angles, you guys remember when we look at the cast diagram, we are always working in an anti-clockwise direction, eh? When we read from the cast diagram, we're going anti-clockwise. So when we're going to have negative angles, we're going to move in a clockwise direction. You can also draw the cast diagrams along for me. That cast diagram. Okay, while you're drawing it, I just want to explain to you what's going on here. So, you know this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. So when I talk about the angle that is 180 degrees plus theta, let's pretend theta is 10 degrees. Do you agree with me that will be 190 degrees if theta is 10? So we see that 180 degrees up to there would give you an angle that's 10 degrees there. That would be exactly the same as this. Do you remember what we call these type of angles? Vertically opposite angles. Do you see it's exactly the same? And it will give us the same answer. Right. So that's why we use 180 and 360. Because then the angle will be like a vertically opposite angle. Right, and it works the same in all of the quadrants. Now, if you look at our graphs here on the board, do you remember we said that this first 90 degrees is the part that keeps repeating? At this stage, 10 degrees after 0, you see at where the position is of the graph there. It's exactly the same as 10 degrees before 180. And it's exactly the same as 10 degrees after 180. See that? The only difference is positive or negative. Positive or negative. So if I think about 70 degrees, there it is. Do you see? Round about there. 70 degrees will be on that spot on the graph. And if I go if I look at 180 minus 70 degrees, then it will be at exactly the same place. That's why these reduction formulas work. But you see, it's not the same for 90 and 270. 10 degrees after 0 is there. 10 degrees after 90 is there. Doesn't work. And it's the same. You can look at cos and tan as well. It's the same. From 0 degrees onwards, we have the same effect as from 180 degrees onwards. And the same with 360. So that's why it works. Are you done with the cos diagram? Right, so how this thing is going to help us, you don't know this well yet, but by the end, you will know it very well. Okay, so I want you to write down example 1, so I can show you how it works. Now, theta at this stage is a placeholder for an acute value. Let's pretend it's 50 degrees. No, don't write that 50 degrees. I'm just saying let's pretend it's 50 degrees. So we are looking for an acute angle that will be the same value as the big angle. Now, if theta is actually 50, it means the big angle I'm working with is actually 230 degrees. No? 180 plus 50 will be 230. And that gives me the same angle as when I take 180 out of it, as the 50 degrees. You don't have to completely comprehend this now. I'm just trying to explain to you. This is a big value greater than 180. How much greater? Theta greater. So theta is just holding a place for whatever value. Right? The same with this bottom one. Right. Now what we're going to do is with these ones, they tell us in which quadrant we're in. Then we're going to use the cos diagram to see whether the function, cos, sin or tan, is positive or negative in that specific quadrant. Now, 180 degrees plus theta. Look at what you drew now. Where is it? Which quadrant is it? I'm just asking that. Which quadrant? Third. Who is positive in the third quadrant? Tan. Look at our graphs. Third quadrant is 180 to 270. What is sin there? What is cos there? What is tan there? Positive, no? So we see it here, but we just learn our cos diagram and we don't have to go and draw that every time. Right? So, only tan is positive there. So what will cos be in the third quadrant? Negative. So all you're going to do is you write negative cos theta. So all the ugly things, they disappear. Because negative cos theta will give me exactly the same answer as the cos of 180 plus theta. I'm going to show you this now in a moment with real values as well. The numerator, the denominator, 180 degrees minus theta, which quadrant? Second quadrant. Is cos positive or negative there? Negative. So it's going to be negative cos theta. What's the answer? 1. Cancel out. Okay. I want to show you an example. Let's pretend theta was 50 degrees. Okay. Just want to show you on the calculator. So the angle they're asking for here is actually 180 degrees plus 50, which is the cos of 230 degrees. Now what we've done here is we've said that the cos of 230 degrees will be the same as negative cos of 50 degrees. Ne? Do you understand what I'm saying here? I'm saying I'm going to put 50 in the place of theta. So we're saying 180 plus theta, which is actually 230 degrees. can be reduced with the reduction formula to negative cos 50. You can look here on the calculator. Cos 230, that's the first one, 180 plus 50. Ne? It gives me an answer of minus 0,642. Will you remember that? Minus 0,642. We are saying it's going to be the same as negative cos 50. Negative 0,642. Exactly the same. Okay. So you believe me now. And it's the same with all of them. Right, let's do another example. Example 2. When you're done, I think take a pencil, then you just go and write at the top of this bracket whether you think it's quadrant 1, 2, 3, or 4. Sisu, you are so quiet there at the back. Can you tell me which quadrant is this one? Number 3, that's right. Karobu? This one? Four. And this one, Moses? 4 as well. That's not hard, ne? Okay. But you can only know that if you know that cos diagram that we just drew, and we're using it for all of it, so you might as well get to know it now. Right. Now you ask yourself, what is tan in the third quadrant? Positive. Then it just becomes positive tan theta. You don't even have to write the plus. Right. What is sin in the fourth quadrant? Negative. Now, I told the Afrikaans class as well, you can put in the multiplication sign, okay? Or you can leave the negative sin theta in brackets. But just be careful, because later on we're going to have a lot of things happening at once, that when you do this, tan theta, and you put your times with a point, that you don't miss that point. So that you think this is tan minus sin, when it's actually tan times negative sin. So just be careful there. Okay? And then what is tan in the fourth quadrant? Over negative tan theta. Now we can just simplify, right? I can cancel the tans. Right? And then there's a negative at the top and at the bottom. What is it? Positive. No. Positive sin theta. Right, example 3. Can I go to the next page? You got this. Example 3. 1 minus tan squared 360 minus theta. You see there's that square. And there's a minus, not a negative. Who taught you in grade 7? Mr. Olivier? Yes. Do you remember he was very strict about negative and minus. Remember that? He was right. There's a difference. It's coming in here. Okay, which quadrant is this 360 minus? Fourth quadrant. Okay, what is tan in the fourth quadrant? Now look at the way I write it. I say 1 minus negative tan theta squared, because remember I'm just squaring this part. This one. And when I square a negative, what does that become? Positive, but not that one. This one. And you don't multiply the signs before you square, because Botman says you must do the exponents first. So that one becomes positive, and then tan theta times tan theta is just tan squared theta. So that's your final answer, 1 minus tan squared theta. Right, now the activity or the exercise we're going to do, I want us to do number 1 together. So all you're going to do, you don't have to open your books, you can just look here. I'm going to go and ask all of you. All I want to know is you're going to give me the answer. This is now, for instance, positive tan theta or negative cos theta. Alright, now you can look here. We'll start with you. No, I'm helping you. Come. Shush. Hi. Which quadrant is this? The third quadrant. Is sin positive or negative in the third? So it's going to be negative sin theta. Is that too hard for you, Mamelu? 180 minus theta. Second quadrant. What is sin in the second? So it's positive sin theta. You got it? Ne? Right? Hope. 180 minus which quadrant? Guys, come on. 180 minus which quadrant is it? No, where's the first quadrant? Look here. There it is, even on the page. There's the first quadrant. Guys, so where's 180 minus? The second. Is cos positive or negative in the second? Negative. So it's negative cos theta. You all understand that? Yes. Who says no? No, you don't write it down. We're just doing this like this quickly. We're not wasting our time. D, Ayanda. Fourth quadrant. What is cos in the fourth quadrant? Positive cos theta. Thank you. E. Huh? Why are there some of you talking when I am talking? Because then it's fine. I stop talking. I'll give you the homework. You go on. We'll start with you, Tila. What is tan in the fourth quadrant? Negative tan theta. F. Look, F. 180 plus. Third, what is tan in the third? Tan. Positive tan theta. Okay. Third quadrant. What is cos in the third? Negative. But this one has got a square. So what's it going to be? Positive cos theta. Cos squared theta. Okay. Fatima, 180 minus theta, which quadrant? What is tan in the second? So what's this final answer going to be? Positive tan squared theta. Okay. 360 minus? What is sin in the fourth? So what's this final answer going to be? Why? It has a minus, ne? Okay, but the original negative was squared, or the negative I got from the quadrant. Okay. Alright. Now, you are going to, you have enough time, the Afrikaans class also finished it. We're going to do A, B, C and D now in class, but we're also going to mark it. Right. It is on page 141. So use your time. You're going to do that. And I know you are writing a test tomorrow, but I'm going to give you one more thing to do before you throw a tantrum. Let me just show you. It's on the next page. All I want you to do is this discovery exercise. So they say use your calculator to calculate the following. So all I want you to check out is what is sin 10, what is cos 80, what is sin 20, what is cos 70, what is sin 30, what is cos 60, what is sin 40, what is cos 50. So that's just typing it on your calculator. It will take you 10 seconds. That's just the next page, page 142. But now in class we do number 2, and I want to just talk to you about what they gave here. Take note of the following. You must remember that trigonometry and algebra goes hand in hand. It's very much the same. So what was the answer when you said x plus x? 2x. So what's it going to be if you have cos plus cos? 2 cos theta or whatever. Okay, so that's what they're saying there. If it's cos theta plus cos theta, it's 2 cos theta. If it was cos theta times cos theta, cos squared theta. Okay, and what they're saying next to it is they say if you've got sin 180 minus theta over cos 180 minus theta, you cannot cancel the 180 minus theta without the functions. But you guys know that most because we spoke about it last week when we said the sin of an angle, the cos of an angle, and the tan of an angle, it's a ratio. It's a numerator over a denominator. It cannot be separate. Do you remember? Yes. Okay, so that's all they're saying there. Right, you can start. Someone's hand was up. Okay.